Application of electrolysis. Electroplating. Here, we'll discuss the example, nickel plating. This is the electrolytic cell of electroplating. During electroplating, the object being plated must be connected to the cathode. The electrolyte used must contain the plated metal ion. Here, in this case, nickel 2 ions. We should use nickel to be the anode as well. The electrolyte nickel 2 sulfate ionized to give nickel 2 ion and sulfate ions. Nickel 2 ions gains electron to become nickel metal at cathode. A very thin and even nickel coating is electroplated on the object. At anode, nickel lost electrons to become nickel 2 ions, just like the electrolysis copper 2 sulfate using copper electrodes that we have talked about before. The second application of electrolysis, purification of impure copper. This is the electrolytic cell. A pure copper rod is connected to the cathode. The impure copper object is connected to the anode of the electrolytic cell using copper 2 sulfate as electrolytes. The impurities in the impure copper object might contain metals more reactive than copper, such as iron or zinc. Or it may contain a metal that is less reactive than copper, such as gold, platinum, or silver. During the electrolysis, metals at anode dissolve in the sequence of zinc, iron, and then copper. That is according to their metal reactivity series, as you know that zinc is more reactive than iron, and iron is more reactive than copper. At the meantime, a sludge of gold, platinum, and silver will be left at the bottom of the impure copper object. At cathode, only copper 2 ion discharge to become copper and deposit on the copper cathode. Copper at anode gradually transfer to the cathode, and the cathode becomes bigger and bigger. The third application of electrolysis is the anodization of aluminum objects. The purpose of aluminum anodization is to increase the thickness of aluminum oxide on the surface of aluminum in order to increase the corrosion resistance of aluminum objects and also for the dyeing of aluminum. Here is the electrolytic cell of aluminum anodization. It comprises of a graphite cathode and aluminum object connected to anode using dilute sulfuric acid as the electrolytes. Hydroxide ions will be discharged preferentially at anode to give oxygen. The aluminum object reacts with the oxygen there to become aluminum oxide. This oxide layer attached firmly on the surface of aluminum object.